Geometry, lesson 61, determining if a quadrilateral is a parallelogram. Essentially, this goes back to the 4 rules of parallelograms that we already looked at. Can anybody tell me what one rule of a parallelogram is? We had 4. Can anybody tell me what one of them is? Opposite sides, what? Opposite sides are congruent. Okay, opposite sides of a parallelogram are congruent. Can anybody give me another rule? Diagonals bisect each other. Very good, that's 2. Can anybody give me another one? Properties of parallelograms. Come on. Opposite angles are congruent. Good. And Austin started one. Something bisects. Actually, I think that's already on our list, right? The other one, this is maybe the one that gets forgotten the most. Consecutive angles are supplementary. Consecutive angles are supplementary. All right, so we're going to look at parallelograms, and we don't already know, those rules of a parallelogram say, hey, this is a parallelogram, therefore solve these parts of a parallelogram. What we're doing today is that we're looking at something and trying to determine, based upon the information that I have, is this a parallelogram or not? Okay, so it's going to draw back on those 4 rules quite a bit. So we find here, identifying parallelograms, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Going back to that rule number 1, opposite sides are congruent in a parallelogram. This says if I have a quadrilateral and those opposite sides, both pairs have to be congruent, then it's a parallelogram. Okay? If I can draw this, you can draw this. You guys can write these things down. Right? We're recording it. Hopefully you guys can go back, watch it, work on some of this. We're going to try to get through this quickly. All right. Jesus, you seem mildly distracted. Could you read this identifying parallelograms for me?
Sides of a quadrilateral.
No, we're on the next one.
If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram.
Right, that matches up with that second rule of a parallelogram that we looked at. So this one says, though, if it is a quadrilateral and I see that my opposite angles are congruent, then I have a parallelogram. Pretty basic so far. Okay, now we're going to get into one that's a little bit different. Okay. Miss IL, can you read this one off for me?
One pair of opposite sides of a quadrilateral.
Yeah, quadrilateral is a hard one to say. That's why I went to college, so that I could say quadrilateral over and over and over again in front of people without messing it up. So quadrilateral, keep going.
Both parallel and congruent, then the quadrilateral is a parallelogram.
Yep. Okay, so this one actually mixes 2 things. If I have a pair of sides that are both parallel and congruent, then I know it's a parallelogram, because it's going to force B and C and AD to be congruent and parallel. Okay, so this one's kind of unique. All right, let's look at this one. This one kind of goes back to those original rules. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, so they're going to give me measures and things like that, and I'm going to determine, hey, is this a parallelogram or not? Okay, parallelogram is another one that is fun to say about 1,000 times a day. Okay, lesson 62. This is totally different, and that's the way Saxon is, right? We don't, take one lesson, okay, and this one's talking about parallelograms again. It's not. This one's going to talk about surface areas and volumes of cylinders, things that look typically like that, look like a soup can, okay, or like that, okay, just so we're aware they're not always standing upright, sometimes they're laying down. It's not going to change the surface area or how we find the surface area. It's not going to change the volume or how we find the volume. It's not going to change the lateral area or how we find the lateral area, okay. All right. From here, we need to know some things. Okay? Base of a cylinder. A base of a cylinder is one of the two circular surfaces of the cylinder. Okay, so this right there is going to be a base. Okay, I could also have a base on the bottom. Okay, just like whenever we were working with our prisms, except it's no longer a prism, it's separated because it's a circular base, we call it a cylinder. The altitude of a cylinder is the segment, okay, that is perpendicular to and has its endpoints on the planes of the bases. So that is my altitude. And that is my altitude even if, okay, even if it's on its side. Okay, that is still my altitude. It's still my height, even if it's laying down. Okay, and that's one of the things that we mess up with triangular prisms, cylinders, those types of things. We have to remember that the definition of an altitude doesn't change based upon its orientation. Okay, everybody with me so far? All right. Okay, radius of the cylinder is the distance from the center of the cylinder's base to any point on the edge of the base, which makes sense because as a circular base, all right, we all know what a radius is. So lateral area, this is the first formula we really want to write down. Lateral area is like taking the label off that soup can, right? It's going to be a rectangular shape. We're going to find it by taking the circumference of that circle times the height. So our formula, although it's hard to type, our lateral area equals 2 pi r, that's circumference, times the height or the altitude. Okay? It might be better, you might understand a little bit better if you relate that height to actual altitude. Okay? So my circumference times the height. Imagine for a second, I know you won't be able to see this on the video, but I'm going to hold up a sheet of paper. Okay? Now, we could find the area of this relatively easy, right? Length times width. But what I want you to see is that if I roll it so that I take the longest points and roll it over together and have them touch, right? Now what I have is a cylinder. The paper here represents lateral area, okay? Would represent the label that goes around. So, but if I couldn't take the label off, what I would find is the distance around by using 2 pi r and then the height. The height is the width of the paper, okay? The circumference is the length of the paper, right? It's going to give me the same measurements of this. I don't know if that helps or not, okay, to be able to see that. Okay, so that's lateral area. Surface area, just like when we were talking about prisms, is like wrapping it or spray painting it or whatever. I mean, it's the area of the entire thing. So we would take the lateral area that we found, and we're going to add what was missing, which is the bottom base and the top base, okay, which should be the same things. Okay, so our formula for surface area can be broken down into my lateral area, which is 2 pi r h plus 2 times my base. And those bases are circles, and we want the area of those bases, so it's really 2 times pi r squared. So that is the complete, unabridged version of how to find the surface area of a cylinder. Okay, 2 pi r h, okay, where r is radius and height is altitude, okay, plus 2 times the area of the base, pi r squared is the formula for area of a circle. Okay, finally, volume of a cylinder. Volume of a cylinder works just like the volume of a prism. We take the area of the base polygon and multiply it by the height or the altitude. So to write it up here, just so we're seeing it a little bit easier, area of the base polygon, which is pi r squared, because it has a circular base, all right, times my altitude or height. Okay, imagine if you wanted to find the volume of a deck of cards. You could find the area of one single card and then multiply it by how many cards that you have depth-wise, right? Those are going to stack. So that's how this works. You take that bottom area and then you stack it, and that stack is my altitude or height. Okay, I know I spoke really quickly through a lot of this, but again, it's for the purpose that you can go back and watch it, listen to it again, watch it again. Okay, so we should have our formulas down, hopefully, and I don't see a lot of this where people are actually writing things down, right? I see a couple of you writing some things down, okay, but we should all be writing things down. Okay, a couple of you are typing some things up. Good. All right. I don't know, I don't think that there's anything else involved in the notes from here on. So let's go to 61, 62 and look at this. All right. Question number 1. If a can is 20 inches tall, okay, that's my height or altitude, and has a radius of 8 inches, how many cubic inches of water can the can hold? Are we talking about lateral area, surface area, or volume? Volume. So what was my volume of a cylinder formula? Volume equals what? Pi r squared height. Okay, so now all we need to do is substitute. What is my radius? 8. So I'm going to square 8 and multiply it by my height, which is what? 20. Now, if you'll notice in the answers how they leave pi out, which means I don't need to include pi. So what's 8 squared? So all I need to do with my calculator is take 64 times 20. What's 64 times 20? 1,280. But I do need to include my pi, 1,280 pi inches cubed. All right, are we good? Do we understand that? All right, so if they're talking, and we really should have had a hint with cubic, and then when we're talking about water, we're talking about volume it can hold. All right, question number 2. Oh, goodness. All right, come back up here. 2, for an art project, and it needs to spray paint a soup can on all sides. So am I talking about lateral area, surface area, or volume? What is the lateral area? Can anybody give me an example of lateral area? Okay, so a label around a soup can. What wraps around it? Does it include the top or the bottom? Okay. What about spray painting all sides? What is that? Is that lateral area? No. Okay, what is it? Is it volume? Surface area. All right, so I need a surface area formula. What is my surface area formula? 2 pi r h plus plus 2 pi r squared. Okay. So once I have my formula, all I have to do with the information is plug in and make sure that I have everything that I need. So I know that I'm going to have my 2. They are actually going to include pi in this, so we'll include pi. Let's see, what is my radius? 3. What is my height? 5. Okay. I make sure to put a dot in there so that I know I'm multiplying 3 and 5 and it's not 35 somehow. Okay, plus 2 pi 3 squared. Okay, I'm going to leave pi out until the very end so that I'm not getting an approximation. So I have really 2 times pi times 3 times 5, but I could rearrange that so that it is pi times 2 times 3 times 5. That's not going to change anything. Plus pi times 2 times 3 squared. Technically speaking, order of operations would tell me to do the 3 squared first, right? Okay? So we know that this is 9 times 2 times pi plus pi times 2 times 3 times 5. Can we do quite a bit of this all at once, though? Sure. Okay, what's 2 times 3? What's 6 times 5? So I got 30 pi there. All right, what's 2 times 9? So I got 30 pi plus 18 pi. What's 30 plus 18? 48 pi. Okay? They don't tell me what to use, but typically these use 3.14. So let's take 48 times 3.14. What do you get? Approximately to the nearest square inch. So what would that 0.7 round up to? 151 inches squared. And I know this looks like a lot of work, but could we have done, could we have even done from here? Could we have jumped to 48 pi pretty quickly? Yeah. Okay, I think you could have done that. Okay, but I want you to see how it's broken up. Okay. All right, let's come down to question number 3. What time did I tell you guys get out? 25? Okay. All right, this says show that GHIJ is a parallelogram for x equals 5 and y equals 8. So what do I want to do with my x's and y's around this? Substitute. So let's come here and we're going to do 3 times what? 8. Okay, and over here we're going to do 5 times minus 16. Okay, and up top we're going to do 5 times 5 minus 10, right? And down here we're going to do 7 times 5 minus 20. Okay, well what's 3 times 8? 24. Okay, what's 5 times 8? 40. What's 40 minus 16? 40 minus 16, is it 24? Okay. Okay, so far, this is congruent to that, right? What's 5 times 5? What's 25 minus 10? 15. Okay, what's 7 times 5? Minus 20. 15. All right, are both pairs of opposite sides congruent? Okay, so what we see in here is that they substituted my 5 in. Down here we see that they substituted 8 in. We got 15, 15, 24, and 24. Both sets of opposite sides are congruent. You should get answer A in there. All right. Let's come down to number 4. Number 4. Show that quadrilateral DEFG is a parallelogram. Okay. They give me quite a bit here. They show me slopes and they show me side lengths, right? So in this, what I want to see is that, let's go ahead and put this in. Slope DE. DE is 3/8, okay? And FG is 3/8. So what do I know about DE and FG? They have the same slope. They are, no, parallel. Lines that have the same slope are parallel. All right, this tells me that DE is radical 73. This tells me that FG is radical 73. That tells me that those two lines are what? That they're what? That they are congruent. Okay, because they have the same length. Okay, so 1, if we complete our explanation, DE and FG have the same slope, so they are parallel. Okay, this is a parallel line. That looks pretty good. Okay, let's see. Since DE is equal to FG, they are congruent. Because of, because one pair of opposite sides are parallel and congruent, okay, DEFG is a parallelogram. So B, one pair of opposite sides is parallel and congruent. B works for that. Okay, that's where we want to go back and we it's important that we look at those notes before we start answering questions so we know what we have available to us. Okay? I think we can get, maybe not. I think maybe that's probably a good place to stop right there. But here's what I'm going to do. Because this only goes to 12 questions, I'm going to break this up into 2 parts. I'm going to finish the other part with the other class. I'm going to submit both videos to your classroom. You guys should be able to get this assignment easily done by Monday. Okay? All right, it's not a super big assignment, and you guys will make sure that you go back and watch the second half of the notes. All right, we'll stop right there.